We're talking today about similar figures. Similar figures are figures that have the same shape, but they're not necessarily the same size. Okay? So they're both triangles. They both have exactly the same angle measurements, but maybe one side is proportionally larger or smaller than another. For example, if I have a similar figure, let's take this pentagon. Okay, this might be one of my figures. And then I may have another pentagon that's larger. Okay, they're the exact same size, or I'm sorry, they're the exact same shape, not the same size. They're the same shape, but they're not necessarily the same size, and therefore they are similar. Okay, now if I took a look at this figure and I numbered the sides of my figure, okay, and this one, okay, looking at these two figures and the way they are oriented, side 1 and side 6 match, so they are corresponding sides. Okay, and then this angle and this angle match, so they are corresponding angles. Okay, so the sides of similar figures that match are corresponding sides. Okay, so 1 and 6 correspond, 2 and 7, 3 and 8, 4 and 9 correspond, 5 and 10 correspond. Okay, you could also take a look at this with, let's see, triangles, things that don't have similar or equilateral sides. Here's an item that does not have equilateral sides. This is a trapezoid. Okay, so let's say I have these two trapezoids. They're similar or proportional to each other in size. Side 1 here would correspond to side 5 there. These are matching sides. Side 2 and side 6 would go together. 3 and 7 go together. 4 and 8 go together. Okay, so my corresponding sides here that match are 1 and 5. Okay, so that's a corresponding side, and then of course your corresponding angles are the ones that also match. This angle and this angle match, so they are corresponding. All right, now that we have determined what exactly a similar figure is, what does similar mean? Similar means that they are proportional to each other when we're talking about two different figures. And you can determine if figures are similar by seeing if they have proportional side lengths. And let's take a minute to review how we figure out if something is proportional. If we have two fractions, 1/5 and 3/8, we can figure out if it's proportional by cross multiplying. 5 times 3 is 15. 1 times 8 is 8. These are not proportional because their cross multiplying does not come out equal. However, if we had something like 1/5 and 3/15, when we cross multiply, we get 15 for both sides. So this is a proportional figure. Okay? All right, so how do we do that with a similar figure? Find out if it's proportional. Well, what we're going to do is we're going to look at our corresponding sides and our corresponding angles. First of all, you can see that the corresponding angles, this one is angle S and this one is angle Y, they are both 26 degrees, so they're the same. So that's one clue on whether our figure is similar or not. Do the angles match? So now this one's 118 and that one's 118. That's similar. and then the 36 and the 36. So we know that our corresponding angles match up exactly. So that's one way to tell that this is a similar figure. If we didn't know what our angle measurements were and all they gave us were side lengths, we would be able to prove proportionally that these two angles are similar. So what we could do, let's say we have side SR here. Whoop, let me draw that a little straighter if I can. You know my issues with these things. Okay, SR is right there. So line SR is worth 4 centimeters. Okay, its matching on the other side is YX. And YX for the small triangle is 2 centimeters. So when we write our proportion here, our labels here are going to be large and small. The large triangle measurements will go on top. The small triangle measurements will go on the bottom. So for the large triangle, side SR matches with side YX. So those two go here in our first fraction for our proportion. Now we're going to pick another set of matching sides. So I have line ST, and ST is worth 6 centimeters. And its corresponding side is YZ. And YZ is worth 3 centimeters. Okay? So now I have this proportion set up, and I'm going to see by cross multiplying 6 times 2, is that equal to 4 times 3? Okay, so 6 times 2 is 12, and 4 times 3 is 12. Yes, they are equal. So this is a proportional set of side measurements. Now, if one set of sides is proportional, it still doesn't necessarily mean we have a similar object, because we may have multiple sides, maybe a 10-sided figure, and maybe the sides that we picked were proportional but the other ones are not. So we're going to need to check one more proportion and make sure that our figures are similar here. So let's do, once again, let's do SR and YX. So SR, once again, is 4. YX, once again, was 2. And now let's choose our other two sides. We have RT for the large triangle, which is worth 3, and XZ for the smaller triangle is worth 1.5. All right, does 2 times 3, going this way, equal 1.5 times 4? Okay, so 2 times 3 is 6. Does that equal 1.5 fours? Well, I know that half a 4 is worth 2. So 1.5 fours would be 4 plus 2, and that is also 6. So these are equal, and they are similar triangles. Now, in this kind of a problem, which trapezoid below is similar to trapezoid DEFG? So first we have to look for trapezoid DEFG, and here it is right here, DEFG. This is our trapezoid. One of these is similar to this trapezoid. We can't just guess. Looks can be deceiving, so we have to make sure that we do the calculations, because these figures might not be drawn to scale. So what we're going to do is we're going to set up proportion. Now, if any of the sides don't match proportionally, then it is not a similar figure. So we are going to work with DEFG on the top, and we're going to do the other trapezoid on the bottom. Okay, so for DEFG, let's look at, we've only got 2 sides to work with here. Let's do EF is 4. And for this first trapezoid down here, our matching side is QR, which is 6. Does that equal GF here, which is 12? And SR is the matching or corresponding side of this other trapezoid, SR, which is 14. Okay? Now, 6 times 12, does that equal 4 times 14? 6 times 12 is 72. Okay? And 14 times 4 is 56. These do not equal each other. This is not a proportional triangle. Okay? Or I'm sorry, a proportional trapezoid. All right, so let's start over. Let's try the middle one. We're going to set up our proportion here for our middle trapezoid. Now, once again, EF is 4. Okay, so EF with the line over the top means that is segment EF is worth 4. Segment XY is the corresponding side, and it's worth 3. And then we're going to look at GF again. Segment GF is worth 12, and segment ZY is the corresponding, and it is worth 9. Does 9 times 4 equal 3 times 12? Let's see. 9 times 4 is 36. 3 times 12 is 36. We looks like we might have a winner here, so this one is similar. Let's do the last one just to make sure that we've got the right one. And we're going to look at segment EF is 4. And the matching segment, corresponding segment, is KL. And that is 5. And then GF is 12. And the matching or corresponding segment is ML. And that is 10. Does 5 times 12 equal 4 times 10? Well, 5 times 12 is 60. 4 times 10 is 40. I'm going to put a line through this equal sign. That means does not equal. 60 does not equal 40, so that's not similar. So this one is also a no. So our yes trapezoid is the middle one. It is the similar trapezoid. Okay, now you might have a word problem. Looking at this one, Old Faithful here. Old Faithful in Yellowstone National Park shoots water 60 feet into the air. So here's Old Faithful over here, and it shoots water 60 feet into the air. Okay, and that water casts a shadow that is 42 feet long. Okay, so now we've got two things here. We've got the height of the geyser and the shadow. So my two labels for my proportion that I'm going to be making are height and shadow. Okay, so now the tree, we don't know that height, it's X, but we do know the tree's shadow is 63 feet. So making our similar figure proportion, the height of the tree over the shadow. So we know that the height of the geyser is 60. So I'm going to put geyser here. And the shadow of the geyser is 42. Okay. The height of the tree is X, and the shadow of the tree is 63. So now I have my shadow numbers on the bottom, my height numbers on the top. And so we have to figure out 60 times 63 is equal to 42 times some other number. Okay, so 60 times 63 3,780. And then that equals 42 times some number. So we're going to have to divide by 42 to figure this out. So 3,780 divided by 42. Well, I know 42 is almost 50. So I'm going to estimate with 300 that would be 6 times. And then 78 that would go in 1. So that's at least 7 times that 42 is going to go into 378. Okay, so if I estimate this 50, 50 would go into 300 6 times. Plus 1 more for the 78, that's 7. So let's do 42 times 8 here and see what happens. Okay, so that's 16, that's 33, 336. I think that'll work. Let's see. Let's do 42 times 9 just to make sure. That's 18. Oh, look at that. That's 378 perfectly. So we're going to put a 9 here. Okay. And fill in with our 0 for our last place value. So 90 feet is the height of the tree. Okay. All right. Let's try another one. One trick that you might do if you have 2 items, and in here Destiny wants to resize a 4-inch wide by 5-inch long photo for the school newspaper. It has to fit in a space that's 2 inches wide. How tall is that picture going to be? So one thing you can do if you have similar figures set up right here like this, right next to each other in the same orientation, and what I mean is they're both with the long side going up and down. If they were one with the long side going left and right, the method I'm about to show you does not work. They have to be in the same orientation with the long side up and down. They have to be looking exactly the same. Okay, if they look exactly the same, then you can decide what your proportion is going to be by drawing a plus sign. All right, and that might help you. And we'll talk more about that individually if you want to learn that method. So for this one, we're looking at the height of the first one is 5 inches. The height of the second one is x. There's more than one way to make a proportion with similar figures. The width of the first one is 4, and the width of the second one is 2. Okay, so I have my large figure here and my small figure there. The large is 5 by 4. The small is x by 2, according to our corresponding sides. Now, 5 times 2 will equal x times 4, and I'm going to write that 4x. The x should always come second. So I know that this is 10 equals 4 times something. To find out what that something is, I've got to divide by 4, and x ends up being 2.5 inches. Looking at another one, this one is given to us. The figures are similar. That information is already given to us, so find the value of x in each pair of similar figures below. Similar figures mean they must be proportional. Okay, if they are similar, then their sides are proportional. So we're going to do large over small again. All right. So in our large figure, WU is 20. And in our small figure, ZX, the same side is 4. Okay, the corresponding side. Now for our large figure, UV is X, and our corresponding side in the small figure, XY, is 7. So now we have 4 times X has to be equal to 20 times 7. Okay, so this is 4x equals, and 20 times 7 is 140. All right, we're going to divide by 4 on both sides to find out that x equals, let's see, 4 will go into 14 3 times with 2 left over, so 35 for x, 35 meters.